Hey, how's it going, everybody? Hope you're doing well. Sorry I haven't put up a video up in a while. That's, Call of Duty Ghosts. Psh, that's what's up. Nah, but I hope you guys are having a good day. And today, let's get into some physics. Momentum and impulse is what we will be talking about today. So let's get ready to go. We'll jump right into it. Oh, what's going on? All right. First question is, why is it hard for you to stop a speeding car with your bare hands? Why do you think that that's challenging? Okay, yeah. Well, a lot of the students were saying that because the car is very heavy. The car is super heavy. And so that's why it's kind of hard, and the car is also coming fast. So it's heavy and fast, and it would, hurt you to do it. And the next one, why is a baseball easier to catch than a bowling ball? If I threw them at the same speed at you, which one would be easier to catch? The baseball. Why is that? Yes, because the bowling ball is heavier. So we see this word again. Oh, I think I misspelled heavier. We see this word again. We say heavy here, we say heavy here, and we say fast up here. Those two things are exactly what we'll be talking about today. So let's go. Alright, the answer to those questions is momentum. Momentum is the reason why those things are hard to do. And to find an object's momentum, all you need to do is multiply the mass of the object, remember that's in kilograms usually, by its velocity, that's meters per second. Multiply those, and you have momentum. Super easy. Alright, that's it for momentum and impulse. I'm totally just kidding. Alright, next one. Okay, how to write momentum. Let's figure some stuff out about momentum. Here's some rules about it. Well, first of all, because scientists and physicists are pretty smart, they decided to give momentum a variable. You know how velocity was just letter V? Good. And then you have initial velocity and final velocity, initials VO or V naught or VI, whatever you want. Your final velocities, they have VF, V, whatever. Well, acceleration is what variable? Yes, it is. It's A. Time is T. Well, momentum is obviously going to be... No, it's not M. Good guess, though. Momentum is going to be P. See that P right there? And it says P, exclamation point, this IKR. That means I know, right? I know. I don't know. It's just a P. In any case, regardless, we're going to use P to represent momentum. Because there's obviously, that's the first letter we all think about, is the letter P when we see the word momentum. Okay, here's some important stuff. Write this stuff down. P, what was that again? Oh, that's right, that's momentum. Momentum is equal to the mass times the velocity. That's it. To find momentum, multiply mass times velocity. The units for momentum are going to be kilograms, meters per second. That's pretty straightforward. Your mass is kilograms, velocity is meters per second. That's the units. But you will also see it as a Newton second, which is a capital N for Newton second. There we go. Also know that P is a vector. You know what vector is? What vector means again? If you don't remember, think about Despicable Me. I am vector, committing crimes with magnitude and direction. Yes. Oh yeah. Magnitude and direction. That means that if you get a negative number, what does that negative mean? That it's going to the west, usually, because usually we go positive numbers to the east. That's probably going to the west, or it could be going downwards, but most of all, it's probably going to be going to the west if it's negative. If it's positive, that means it's going to the east. Alright? So, let's go to oh, wow, first example already. I wasn't even ready for it. Here we go. Oh, I guess so. Here we go. Example of momentum. By the way, these are the easy ones. So we'll get to these 3 easy ones, then we'll go into some medium ones, then we'll get into a hard one. And I'm sorry that these videos are so long. I just try to get all the information into one YouTube video. That way, you don't have to click on this one, then click on the next one, then click on the next one. That it's all here. Everything about momentum, except, of course, for the conservation of momentum, is going to be here. So here we go. Number 1. A 100 kilogram bicycle travels at a speed of 20 meters per second. What's the bicycle's momentum? Well, let's pick up on this keyword right here, momentum. And write down what you know about it. What do we know about it? Okay, we know that. We know its speed. And yes, that's what we know. We know the formula. P is equal to mass times velocity. Now, do they give us the momentum? Let's see. I don't see any Newton. I don't see any kilograms meters per second here. I don't see any Newton seconds, so they don't give us momentum. Do they give us mass? Here we go. I see kilograms. It's got to be mass. Times. Do they give us a velocity? Yes. I see meters per second. They give us that. So, I guess we just multiply these guys, I'm guessing. 100 times 20 is... don't say 200. Good, it is 2,000. Don't forget to label your units. Kilogram meters per second. Or, of course, you can write Newton seconds. There's your answer. That's your momentum of the object. Oh, what direction is it going in? Well, it's a positive number, so it's got to be going east. Or to the right. Yeah, that wasn't so bad. Heck yeah, momentum's so easy. A baseball has a momentum of 100 Newton seconds. The baseball weighs 0.05 kilograms. Find its velocity. Okay, what are we looking for? We're looking for velocity. But what else do they give us? Oh, I see a special word right here. Momentum. That means we got to use momentum. What do we know about momentum? Yes, we know P is equal to M times V. Alright, did they give us a momentum? Oh, yes, they do. I see Newton seconds here. So let's put the 100 right there where the P is. Do they give us a mass? Let's see, baseball weighs... I see kilograms. That's got to be mass. So 0.05. Find its velocity. We don't know velocity, so we're just going to leave it as V. Alright, so how are we going to do this? Well, the 0.05 is multiplying to the velocity, so let's go ahead and get it off by dividing. We will divide by 0.05 to both sides. And these 0.05s, they reduce to a 1. But I guess you could... don't say they cancel out. They reduce to a 1. They go away. Say that. They go away. It's a non-factor anymore. So you are left on the right side with V only. So V is equal to... then we do 100 divided by 0.05. It is 2,000. 2,000. And its velocity, so it's going to be meters per second. What direction is this guy going in? Well, it's positive, so he must be going to the east. And by the way, that's really fast for this baseball to travel. I made this one up. I'm sorry. I should have put the momentum lower. And even before I made this PowerPoint or video, I should have made it lower. But this is the answer, even though it's not realistic. Alright, next one. This one is realistic. A teacher runs through a hallway at 3.5 meters per second. The teacher has a momentum of 262.5 Newton seconds. Find the teacher's mass. Period. Alright, so let's see. What word do we see here that makes a big difference? Momentum. That's that word we're checking out. What do you know about momentum? Yes. P equal to mass times velocity. Let's see, what did they give us? Runs through a hallway at... oh, wait. I see 8 meters per second. That's got to be... that's exactly right. Got to be velocity. And I keep reading momentum of... oh, I see Newton seconds. That's got to be momentum. Very good. And then I don't see mass. Oh, because we're looking for the teacher's mass. So we're looking for that. Well, this is just like the last problem that we just did. The 3.5 is multiplying to the m. So how do we get it off? You will divide it to both sides. Now what happens to these 3.5s? They go away. Good, I'll take that answer. Your m just falls down. 262.5 divided by 3.5 is 75. So that is 75. This is a mass, so it's got to be in kilograms. And there we go, you're done. That's that answer. So far so good? I hope so. Okay. Ready. Here we go. It's about to get real. As you can tell, because the question got longer, right? So don't be afraid of it. Let's go. A car carrying 4 passengers has a combined weight of 1,200 kilograms, travels east at 40 meters per second. The car drops off 2 passengers and uses some fuel. It is now traveling at 50 meters per second, weighing 800 kilograms. By the way, these weights are not accurate. I just made them up. What is the magnitude of the car's change in momentum? What are we looking for? Change in momentum. So to find a change in anything, you write that as delta P, and that delta P is going to break up into your momentum final subtract your momentum initial. So how would I find momentum final? Well, I know that momentum is made up of mass times velocity. Well, this must be the final mass times the final velocity. Subtract the initial mass and the initial velocity. Pause it right there if you don't get it and go back. So final momentum is equal to final mass times final velocity. Subtract our initial momentum, which we find by getting the initial mass and the initial velocity. So let's go. Let's create some stuff over here. What could our... As we read the story, what do we see? 4 passengers. I don't really care about that. Combined weight of this much kilograms. Okay, I like that, kilograms. So that must mean that 1200 is some kind of mass. Is that the initial mass or is that the final mass? It is going to be initial mass because it's what they started off with. So you got your MI is equal to 1200. It travels east at this many meters per second. So that 40 has got to be your VI because it's right there with your MI. The car drops off 2 passengers. I kind of don't care about that. Uses some fuel. It is now traveling at 50 meters per second. So it was at 40. That's your initial. Now it's at 50 meters per second. That's your final. And it is now weighing 800 kilograms. So if I multiply these guys, if I do 800 times 50, and then I do 1200 times 40, then I will have the pieces that I need to plug in. So let's go. 800 times 50 is, good job, 4,000. 4, 1, 2, 3. Oh, wait. It might be 40,000. Let me do it. Thank you for telling me. Yes, it is 40,000. One more zero right there. Alright, and then we do 1,200 times 40. We end up getting 48,000. So this is my PF. This is my PI. What am I going to do with those values? We are going to subtract them. Don't make the mistake in putting the 48 first just because it's bigger. Just put them in order. Put the final, subtract initial. The final was 40,000. Subtract, what's your initial? 48,000. Subtract those, you end up getting a negative 8,000 Newton seconds. Because it's a negative, what direction was it going? Or did it gain or lose momentum? It lost momentum because this is going to the west. Alright, now watch this note right here. Whenever you find the change in momentum, that means whenever you subtract the final, whenever you subtract the initial from the final, whenever you do that, you're actually finding the impulse. That's all an impulse is. It's a change in momentum. That's it. Let's go. Impulse. If you go online or Wikipedia it or Yahoo it, Google it, whatever you choose to do, you will see impulse written as, oh, by the way, let me tell you this. Impulse. What variable do you think they gave to impulse to represent impulse? Yeah, super good. I'll give you a clue. No, it's actually a J. But good job. I know. Okay, so impulse is going to be represented as your change in momentum. This delta, that means change in P is momentum. So you read it as impulse is equal to the change in momentum. So that's how they write it. Here is how I want you to write it. Always write it like this. J is equal to, how'd you break up momentum again? P final, subtract P initial. Now how do we break that up again? Your mass final times velocity final. Mass initial, velocity initial. I want you to write it just like this. By seeing it just like this, you'll see all the pieces that you need. You need 1, 2, 3, 4, 5 pieces. So if you can write this down, you'll be in good shape. So don't really worry about this top equation. Just be aware that that's what it looks like. And this bottom part is really what it means. That's the way I use it all the time. Alright, here we go. Let's start on this one. A 5-kilogram skateboard waits for someone to play with him. I should have probably put it. Okay. A 40-kilogram skater gets on the skateboard and begins to skate west at 3 meters per second. What is the magnitude of the object's change in momentum? Yikes. Let's see. What did it say? Magnitude. That just means size. I kind of skip over that. Change in momentum. Not only do we have momentum, but we have the change in momentum. That means delta P. So what does that mean? That means we're going to be finding the impulse. So let's write down our equation, our new one that we have. Mass final times velocity final, subtract mass initial times velocity initial. And that will give us our change momentum. Well, let's see. I've got 5 kilograms waiting for some, okay. So this might be the mass initial, the first mass. So I'm bringing down the negative sign that was part of the equation. Got my 5 there. Now let's find the initial velocity. Waits for someone to play with him. If he is waiting for someone to play with him, is he moving? He is not moving. So his initial velocity is 0. A 40-kilogram skateboarder gets on the skateboard and begins to skate west at 3 meters per second. So initially it was a skateboard by itself, so that's 5. Now a 40-kilogram skater gets on it. So the skateboard by itself is 5. A person gets on the skateboard and weighs 40. What are we going to do with that 40 and that 5? Very good job. We are going to add them together. So you add them together and you will get your final mass. 40 plus 5 gives you a mass of 45. Now how fast was it going at the end? It's going 3 meters per second. There's your velocity. But it's going west. That means that 3 is going to be negative. And this will be equal to your impulse. So let's see. Next step is J is equal to, J is impulse. 45 times negative 3 is negative 135. Negative 5 times 0, that just goes away. 0 times anything makes that go away. So you are left with negative 135 Newton seconds. Why is your impulse negative? And what does that negative mean? That negative means it's going to the west. And wasn't he going to the west? So his momentum changed by 135 newtons to the west. Newton seconds. Alright, here's the biggie. This is it. This is the big one right here. The impulse momentum theorem. You ready? Here we go. This is how they will write it for you. Oops, I already messed it. They write down J is equal to, that's impulse. Impulse is equal to your change in momentum, which is equal to your force multiplied by your change in time. Alright, see all this? I hate writing math horizontally like this. It confuses me so much. It makes my work messy. So here's how I want you guys to write the impulse momentum theorem. Alright? The impulse momentum theorem, you will write it like this. You will write M final, V final, subtract mass initial times velocity initial equal to force times time. Please write it like that. Keep it just like this. Please. Please, please, please. If you have it like this, you'll do well. It'll keep your work nice and neat, and you'll see how we use it in a little bit. And the impulse momentum theorem, well, it basically, what it says is that now you can set the impulse equation equal to force times time. By the way, I put well basically because it's a thing in class that we talk about, like words that I don't like. Oh, basically is one of those words. Bang bang, that I don't like. Alright, next one. Let's put the impulse momentum theorem into practice. Here we go. Let's read this question. Blah, 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 blah. What is the average force? What? Force? Now we got to use some weird stuff? I don't know. But let's just write down our impulse momentum theorem. I don't know. Maybe that'll work. You've got your mass final times your velocity final. Subtract your mass initial times velocity initial equaling to force times time. Please write this down. This is your key equation. Don't use any of the other ones I just showed you. This is the mother. This one's the one of all of them. This is the winner. Let's plug in some stuff. A 2,200 kilogram SUV. Oh, that's got to be some kind of mass, right? Well, it's got to be initial because it's starting there, so that's going to be our initial mass. I'm bringing my subtraction sign from the formula, writing my 2200, waiting for my initial velocity. Let's see. Traveling at 26 meters per second, that's got to be his initial velocity. Can be stopped in 21 seconds. Okay, why? That's got to be time, right? 21's got to be time. So I'll put that in there. By gently applying the brakes. What is the average force? Okay, well, I know I'm looking for force. Well, I don't see another mass. I don't see another mass, and I don't see another velocity. Well, we can assume that the mass is not changing. It doesn't say that it lost mass or gained mass or whatever. So let's assume that the mass stayed the same. There's your mass. Well, then what would your final velocity be? We need that piece to get this done. Let's keep reading. Maybe we missed something. Blah, 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 blah. Can be stopped. How fast is it going if it's stopped? 0. Perfect, perfect, perfect. Alright, so here we go. Let's do some work. What happens with this 220, this 2200 and the 0? 0 times that will just make him go away. So you are now left with 2200 times 26 equal to force times 21. Multiply that, the 2200 and the 26, sorry, it's a negative 2200. Negative 2200 times 26. And you get a negative 57,200 equaling to force times 21 seconds. Now, oh, this 21 is multiplying to force. How do you get rid of it? Good job. You got to divide it. Divide it over there as well. What happens to these 21s? They reduce. Now I've got negative 57,200 divided by 21. And you end up getting, I'm going to write the answer over here, negative 2,723. Oh, that got ugly. Negative 2,723.81 newtons. Because that was your force. So it's got to be in newtons. So because the force is negative, what does that mean? Well, it means that the force was applied to the west. The force was applied in that direction. Because wasn't the car initially going to the east? If the car was initially going to the east, oh, we know that because his velocity is positive. If he was going to the east, then you apply this force to the west direction and it will make the car stop. Alright, let's go ahead and go to the next part. Scientific notation, real quick. Hold on, let's see what time it is. Oh, we got plenty of time, guys. Scientific notation, let's see it. You're going to need this for this section. You probably need it for some other stuff, but let's just go over it real quick. If first question is, if you have 187 times 10 to the 7th power, what does that really mean? What number is that? You type it in your calculator, you get this huge number. But let's figure out how the calculator really gets that. Well, let's see. You have the 1.87, and you have 10 to the 7th, right? Well, if it's 10, and all you do is look at the exponent, and you move the decimal that many times. So it says 7 times, right? So let's go to the decimal. There it is. 1, 2, 3, 4, 5, 6, 7. And then you just drop your decimal there. That's where you stopped. And fill in all these empty little holes with zeros. So that number is actually this big old number here. 1, 8, 7, 1, 2, 3, 4, 5. With 5 zeros. What if you had this? I don't know. I just put tons of zeros. If you had this, and you're trying to write it like this, you want to write it in scientific notation. How would you write this in scientific notation? Well, where's your decimal? If you don't see it, that means that it's at the end. That's where your decimal is. Right there. So, and when we do in scientific notation, you have to stop it before it gets to the first number. You've got to stop it right there, in between the 2 and the 1. Or if this was a 5, in between the 5 and the 1. In between you just leave one number hanging out by itself. So let's go. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many times did we move that decimal? 9 times. Okay. And usually when you write scientific notation, they have 3 significant figures. That just means 3 guys here. Maybe you'll have 1 guy there, 2 guys there. I don't know. But usually it's going to be 3. So it's going to be 2.11. We stop the decimal there. Times 10 to what power? Let's see. How many times did we move again? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times, and it's 10 to the 9th power. Let's just recount to make sure. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it is 9. There's your answer in scientific notation. You're going to need that. Because some of the stuff gets really big, and they will write that for you for your answer choices. And you got to know what that means, and how to interpret it, and how to rewrite it. Alright, so going forward, guys, always write down the impulse momentum theorem. I don't care what the problem says. I don't care if it's super straightforward momentum. Write down the impulse momentum theorem, and then eliminate what you don't need. Because it has all that you do need. Remember that momentum is, what letter is momentum again? Letter P. And how do you find momentum? Mass times velocity. Very good. And when you're changing momentum, when you take the final momentum, subtract the initial momentum, what does that give you again? Impulse. What letter was the impulse? J. Very good. And when you have your momentum theorem, all you got to do is just eliminate what you don't need. But you have all the stuff here. Let's see. Oh, find the momentum, and all it gave you was a mass and velocity? I don't even need that. And I don't even need that. Or whatever one. You just do this guy. Or whatever. And that's it. Well, let me just go back to the first one. And let's redo this guy. We see the word momentum. Let's write the impulse momentum theorem. Final, velocity final, initial, velocity initial, force times time. Alright. It gives us initially 100 kilograms. So you can write it initially if you want to. Or you could put it I would probably put it at the end. If it doesn't give you more than one, I'll just write it at the end. So your final velocity is 0. I'm sorry, your final mass is 0. Your final velocity is 20. I'm still waiting for MIVI. Uh-oh. That was a Nelly reference. Alright, do they give us an MIVI? No, they don't, so I don't need that. Do they give us a force times acceleration? Or a force times time? No, they don't. So let's just go ahead and do this. And this is going to be our P, final. And you get your 2,000. Do it like that. Let's try this guy. We'll do the exact same. Oh, yeah, this guy. Yeah, this will be a good one. You got M, final, V, final, subtract, mass, initial, velocity, initial, equals to force times time. Here we go. Baseball has momentum of this. The baseball weighs this much. Find its velocity. Okay. Do they care about force and time here? No, they don't. So I'm going to rewrite it. Well, you don't have to rewrite it. You should just scratch out. But I'm just going to choose to rewrite it. All this is scratched out, so I left that alone. Now it says that the momentum is 100 Newton seconds, and a baseball weighs 0.05 kilograms. Find its velocity. Okay, well, obviously I'm not going to need one of these guys. So let's just scratch him out, because I don't want to deal with that. I got mass. Mass is 0.05. I don't have my final velocity. Now here's what you just got to remember. Well, this guy is momentum. So that guy's got to be equal to 100. And then you just divide. That's part of the weirdest thing you have to do is that part. Same thing here. Just write down your stuff. Mass final, velocity final, subtract. Mass initial, velocity. Force times time. They don't give us any force or time. They don't give us. They only give us one set of numbers. So let's just go ahead and use it here. Your mass is, we don't know. Your velocity is 3.5. Well, when I multiply these guys together, I do get a momentum. So you got to know that part, and then just divide that. That's how I would work this. Here you do the exact same thing. All you do is, this is all the middle part. This is all this is. This right here is the middle. You get that and you're done. Alright guys, hopefully, oh wait, no, here's a good one. Oh, no, you already have it here. You already have this here. I don't know. You're good. If you have any questions, please comment below. Have a good day. Thank you for checking it out. And yeah, I'll see y'all next time. Thank you. Bye.